So we're here to talk about one of the Argonaut initiatives is the Argonaut Scheduling Implementation Guide. And so if you're in the wrong room, then you can leave now. You can leave anytime, but I'm going to go through the overview of the guide. We'll take a quick peek at it. And again, if you have any questions, just feel free to interrupt. We'll keep it pretty informal. Okay, so my name is Eric Haas, and I'm a consultant and a veterinarian, one of the few veterinarians you'll meet in FHIR. I'm also a primary editor of the FHIR specification. If you look at observation, diagnostic report, anything with surrounding orders and observations, you see my fingerprints all over that. Also, working with Brett in the Argonaut group, I've been a primary editor for the Argonaut Data Query Guide, US FHIR, US Core, scheduling, other things. So, doing a lot of profiling and IG writing lately. And so, we're going to go over the Argonaut Scheduling IG. Just a little outline here. We'll just do a few introductions, a little background. Go into some scope and use cases that we define for the guide, and then we're going to look at some of the transactions that we developed through the project. Looking and finally ending up with some future scope ideas, where it's headed, where we are, and go from there. Okay, just briefly in introductions, what is the Argonaut? I stole this from Brett, and it's really fancy. Let's do this. Okay, so what's the Argonaut Project? Just if you haven't heard any of the previous talks by Brett, Argonaut Project is an implementation community comprised of vendors. We get together every year. They come up with new projects. We're not a standards development organization. We take the existing FHIR specifications and create profiles on and create implementation guides to try to promote interoperability within the community. Okay, and there's other Argonaut initiatives. We happen to be in scheduling. Just a little timeline here. Started out with Smart on FHIR, data query, document query. That's what people know. When people talk about Argonaut, they usually think data query. That would be this one right here. But we also have done other IGs, including provider directory, scheduling, which I'm going to talk about. And these are the projects from last year, CDS hook support. And then this year, currently, we're working on questionnaire, clinical notes, and bulk data. And before I get started, I don't want to forget this. I'm going to give a special shout out to a couple of the colleagues that when we were working on this guide. One was Cooper Thompson. Without him, this would not have happened. Brandon LaRue from ZocDoc was really helpful, and of course Brian Postlethwaite, he's from Telstra. He would call in from Australia, probably a horrible hour for him, and really give some meaningful and helpful input. So I want to thank them particularly for help here. So a little bit about the scheduling background. It's going to be based on the Argonaut IG background. It's based on FHIR STU3, and particularly these scheduling resources, these FHIR resources. And you can take a look at them in the FHIR specification. We circle appointment, mostly appointment. There is some use of a scheduling resource as well as a slot resource. And also, we don't want to forget our friends, practitioner, patient, subscription, coverage, and bundle. They're also heavily used within the IG. Oh, yes, go back to that. Yes. Because we do not use appointment response. In our workflow, we're not returning a response. So it's an operation for looking for an appointment, and it actually returns the appointment. We don't get a response. And thank you for pointing that out, because I wanted to make that point. That's why I crossed it out. Okay, yeah. So in the Argonaut, we had to start out. We started out all wide-eyed and bright-eyed and bushy-tailed. Oh, this is going to be great. This is going to be a piece of cake. And then first, I think in the first call, we started talking about scope and use cases, and we had a laundry list. It was like, oh my God, scheduling. all this stuff. And I thought, from my background, scheduling for me means somebody calls up, hey, my kitty needs to be spayed, and I say, yeah, and you look in a book and you write it in, right? To me, that's scheduling, but it's not scheduling in this use case at all. So, but basically, our basic scope and use case was booking appointments, canceling and rescheduling, and searching for appointments. That's kind of the backbone. But lesson number one that I learned, and we learned early on, is scheduling is not that easy. There's a lot going on there. So we had to spend, I believe we spent the first quarter, we devoted a full quarter defining our scope and use cases. We had to really kind of narrow this down because otherwise it would have blown out of proportion. That's one of our early lessons. So we really spent a lot of time looking at workflow and use cases right off the bat.
So is that transferable across your veterinary care as well as healthcare for humans? Those use cases?
They could, yeah. Okay. Yeah, veterinary care is light years behind in terms of interoperability and specifications, but yeah. So we devoted a first quarter defining our scope, and we really kind of had to narrow it down to the simple stuff. We wanted to have appointments that can be made with only basic information. So there's not a lot of dependencies that you have to depend upon, and a lot of assets that have to be rounded up and figured out before you can make an appointment. And in fact, we went ahead and defined some visit types, some common visit types. And as an aside about those visit types, if you look in the specification carefully, you'll see there's in all the appointment-based resources, slot, schedule, and appointment, you have service type and you have appointment type. And in the real world, you don't have service type and appointment type. Those are conflated. So we made up this term visit types because it's really the business types that you'll see out in the real world. And these are the simple ones that don't need a lot of they don't have a lot of really complex business logic and to be able to make a simple appointment. And so by doing this, we ruled out a lot of important use cases that people have asked for and still ask for. One of them is an appointment request where you say, can you make this appointment? For example, I fell off a bike, broke my clavicle, and I had to make an appointment. Well, they made an appointment for me to get my shoulder repaired surgically. You just can't go into ZocDoc and say I want my shoulder surgery done next Tuesday, and it real time returns back an appointment. No, in some cases you have to make a request and then say, yeah, we'll get back to you. So it's not necessarily it's more of an asynchronous response where everybody has to line up their resources and come back. So that would be more like an appointment request versus a simple appointment where you just book an appointment, you ask for an appointment, you get it back. So we ruled out that important use case. And there's a lot of use cases where you need more information. You just can't say, yeah, come in and I'll fix your shoulder. No, you need more information beyond the basic, who you are, how old you are, and sex and coverage information. You need a bit more information. So we don't talk about having this interplay where you request an appointment and then it comes back with a form to fill out to get more information and that kind of thing. That we put on the side as a future item. And then there's this thing we call discovery. And discovery is really where it's where you marry provider directory with appointment. So you're actually looking for the most appropriate service or provider when you make an appointment. So, and there's a lot of other things we rolled out too. There's a bit on the IG you'll see in the first page, home page, and I'll point it out in a minute, is we have a list of future use cases that could be considered. Okay, so here's what we came up with. We wanted to talk about patient-based scheduling. What does that mean? It means the patient is the end user. So we want to have both new and existing patients, which means you might have a situation where you have what we call open scheduling, where you can look for an appointment without being registered with the organization, versus situations where you're going to have to register before you can even look for an appointment. We talk about using the patient portal, the EHR's patient portal. In that case, they're logged in. They already you're already known. The end user is known to the system, the HR scheduler, versus third-party apps like ZocDoc. There's a couple others, and I can't think of them off the top of my head. So I don't want to just plug ZocDoc, but that's the one that comes to my mind. They have a great name. And we also want to talk about situations where either the third-party app is actually using the scheduling service at the HR, but there's other cases like when you book a plane flight, for example. It's a pretty good user experience. You get pretty good feedback, right? You don't sit there and wait for them to go to 25 different airlines and figure out from their systems what's your best appointment. So there's going to be third-party applications that are going to actually pull that or port all that business logic from the variety of organizations into their application server and use their own logic. And then we also have on a provider end, where the provider's at the end user. So you may be standing at the counter and you're talking to the staff and you're saying, I need to fix my shoulder, so when can we get a, and then they call the surgeon or the hospital and they make that appointment for you. So that would be more the back-end service where it's provider to provider creating the appointments, both within and between organizations and both new and existing patients. Okay, so then the upshot of this, bottom line is we create an IG with these I think I see six basic scenarios. I can't count. So we have, in the patient-based scenarios, we have patient portal scheduling with the existing patient. This is this first one, patient portal, this is kind of the base use case, the simplest flow, it's like 4 steps. Use case 2, we have open scheduling with new or existing patients. There's more registration steps in that one. Use case 3, probably the more interesting one is that prefetching open slots. Prefetching means you're going to do some sort of subscription, you're going to get slots in, and then you can do all that business logic on your end. Your end being the third-party application end, so the end user gets a better response. In the provider-based scheduling, really the first case is the main case, scheduling across systems, use case 1. And then these 2 are really specializations. This one actually we don't talk about at all because we don't think it's really useful use case, but it's in there in case you want to look at it. Okay, so we have our use cases figured out. We kind of figured out our scope, and then we had to walk through this. So basically, I'm going to switch over to the IG here in a second, but basically what we have is a series of steps. We walk through each use case step by step, describing the API. And then we use these transactions, and they're all these use cases. My point here is all these use cases, all 6 of those, are based on a very similar theme. They're a very similar theme. Prefetching is a little different, but they all use these same basic transactions. You have these 7 steps you can do in any of these scenarios. The key one being, and it's highlighted, the appointment availability operation. That's kind of the linchpin here. Okay, I'm going to switch out of here for a second and show you the IG and what I'm talking about. Okay, there she blows. Okay, so we have the scheduling IG, and there's a couple links in a couple places in the talk, and I will be posting that so you'll be able to avail of it. It isn't posted yet, but it will be there. Okay, so let's just migrate through here. Okay, so here's our use cases, and I talked about future scope. There's a whole list of things down here where we talk about future scope, but use cases right here, patient-based scheduling, use case 1. The simplest one, let's go through this real quickly. So here we have basically 4 steps. And login, appointment availability search. We can optionally hold that appointment once we get the appointments returned to us. We can choose one and hold one, and then we can book it. So we have the patient login. If we're talking about a patient portal, EHR, that's dealt with by that application. So we don't really worry too much about that. Here, the patient's known, everything's kosher, we're all happy. And then we go to this appointment availability discovery and search. And this really asks the question, when to book, what can I book? And so what you're doing is saying, I want to book for particular time frame for a particular doctor, for example. I want to see Dr. X next Tuesday or next week, let's say that. That's the question you're asking. And so what you're trying to get back is a set of possible appointments you can choose from. So, and then we talk about the set of common visit types. So we kind of restrict this simple use case to these common visit types, because anything beyond that, you're probably going to have to do some more interactions, more questions, more answers, or maybe a request. It may not be just be, give me a list of appointments I can choose from based on this request. Okay, so in a key transaction like here I mentioned before is this appointment availability operation. And here it is, and this is an operation where we're giving these inputs, basically this query input to a server, a scheduling server, and based on that information, they're going to come back with a list of potential appointments that you can choose from, or say, sorry, and I don't think we talked about this in this, and we haven't really talked about this in this guide, but there is a possibility I could say we don't have these, but we could have these, you know. So you may not have what you want, but we can give you an alternative. In fact, I should look in this. I don't know if we actually ever closed the loop on that possibility. But you see, it's a pretty involved list of things you can search for. So it's a pretty involved and complex operation. A lot of work on the server side to return this. Okay. Okay, so that's the key appointment availability operation, and then next slide is going to tell us about. Okay, so again, we're just reviewing that. I think that is the key to this whole guide is the availability operation. It's based on a set of input parameters supplied by the client, and then the server decides whether or not they can send back some available appointments. There's a variety of parameters I just showed you in the previous on the IGs, but things like specialty, practitioner, visit type, for example, and it gets much more involved than that. So after you get the appointment back, or the list of appointments basically, then the end user can select, I want that. Yeah, that sounds good. And they can do one of two things depending on the implementation. They can actually hold that because perhaps they need to add more information. For example, you know, I need to check and see if my coverage information is updated. So, so there may be a period where you request a hold. The server says, yeah, you can hold that for a period of time. And I think we have defined in here how long. And then there's also an operation to release that hold if you need to. But the hold is so that the end user can add more information, or some process can take place before you actually finally book the appointment. And then the final thing would be to actually book the appointment. So the holding and booking appointments are relatively simple and straightforward. It's the getting the possibilities back that's the most complex part of the. I think it is specified, and I have to look in that, but I can double check on that. But I think we do define that. We actually say, you know, the client should release the hold if not going to use it, but then there's probably a time. And I think we just say, you know, the server's going to define that. Yeah, I don't think we actually say how much it is, but it's defined. The server will define how long you can keep it. Yeah. Okay, so once you book the operation, you're done. In a very simple case. There are other, and here's a state diagram, and this is something I'd encourage you to look at in IG. There's a whole table below this, but this is a lot of the booking and holding operations are really changing the status on his appointments. So you propose an appointment, then you maybe make it a pending appointment, and then you book it. So a lot of the operations are going to be manipulating these states on the appointment resource. Okay, so there's other transactions that are involved here. We looked at that first one where we just had a EHR portal or a patient portal where the login is really managed by the portal itself, but if you're using other situations, you have a third-party application, there may be actual registration or patient login steps you need. Includes registration of new patients or fetching a patient ID. It can include collecting coverage information. We actually added just a little bit about coverage because that seemed to be a pretty common use case. So we did delve into coverage and trying to add some coverage information. And the thing that we learned quickly is there's no single workflow for this. It can be done at the beginning, at the middle, or at the end of the process. Now, typically, before you book an appointment, from a scheduling server standpoint, you want to register the patient. So you probably wouldn't do it after you booked. You'd do it before you booked, maybe right before you booked, and maybe several steps before you booked, or maybe at the beginning of the process. So we have discussed registering in the workflows, and oftentimes it's like, it can be here, it can be here, it can be here, depending on your particular workflow. Insurance coverage, yeah. Mm-hmm. Very basic coverage information. Subscriber ID. Okay, now in many cases that's a happy path. You know, you get a list of appointments, you book one, you find one, you book it, and you're done. Yay! And then I think there's like a 25% chance you're actually going to show up, but that's a different topic. So there's also canceling and releasing holds, and there's also rescheduling. Now we didn't tackle rescheduling head on. We just said, okay, if you want to reschedule, cancel that appointment and make a new appointment. But you can actually think, in the future, you might want to think about a more dynamic rescheduling use case where you do it a little more in a more refined manner.
Is there like a period of time that you can still cancel your appointment inside the specification? For example, 24 hours before you can still cancel, but after you can't? Or is there some logic from hospitals to make that available to patients or to clients?
I know we talked about that, but I don't think, I don't have to look at that. I don't think we addressed that. We didn't address that directly, but I know there's some ramifications if you cancel within a certain period of time. For example, you pay. Yeah, you have to pay, exactly, yeah. So, but the cancel.
That logic, I think that'd be the business logic for anyone.
Yeah.
You wouldn't want to build that into spec. No, but you would want to build that into your third-party app to make that.
Yeah, so,
that logic has to come.
yeah. Yeah, the canceling is, again, in this case, it's a patch. It's a request, an API. And if you can't cancel, then it's going to come and reject that cancellation. I'm not sure about that. We didn't really directly address, you know, if you're going to get dinged for this if you cancel. Yes.
What about the cancellation from the provider side? In case the provider itself is not available on the day, and the hospital
Talked about that too. Yeah, I talked to Martin about that yesterday. That's a good question. I forget our conversation. I don't think it really, that's part of our future scope. Let's put it that way. I don't know. I may have to go back and look. I don't recall us having a direct conversation about that. That's a great question now. I talked to you about that yesterday. So if the patient cancels, that's great. If the provider cancels, well, there has to be some sort of a notification, but I don't think we directly have addressed that, and that's a great question. Yeah. We finished this guide up in, I have to confess, we finished this guide up in like February, and I've been jumped into another project, so I have to dust off my memory and remember what we talked about exactly in the guide. But that's a good one. I'm going to write that one down because I think we need to focus on that and address that issue. Okay. Okay, there's another workflow we talked about. Everything has those basic 4 steps with a few patient registration steps in between. But the prefetching slots for a third-party app, such as ZocDoc, or if you're scheduling a plane, such as Kayak or Travelocity, you're going to be prefetching the information. The key difference with this and other workflows is that the EHR scheduler has to share their business rules with third-party applications so that they can create their own business logic on their side. So that's a step. It's out of band. We don't talk about how this is done. You know, you go and visit them and get a spreadsheet or whatever, talk to them. And then the third-party app will develop their own logic to determine availability. So what that means is that third-party app may not use any of these FHIR operations on their side between the end user because they're developing their own proprietary system. Okay, here is a basic 4-step breakdown, I'm trying to simplify this, of how the prefetching works in the IG. You're going to get an initial load of slots, and you define a period of time for a set of actors or a set of services. And then that initial load of slots is periodically updated or refreshed, maybe daily, maybe more frequently. Then you subscribe for scheduled changes. So we're going to say, we're talking about slots now. We're talking about the slot resource. We're talking about the schedule resource. We're not talking about appointments anymore. So you get an initial set of slots. You subscribe for any changes to the schedule. And that's your trigger. There's a schedule change here somehow, and then that leads to change. That schedule will lead to changes in the slot status. So the EHR will notify the third-party app, or it'll send a notification to some endpoint, and the third-party app server will see that, and that will trigger them to repoll for to do what we call smart polling. Poll for the slots that they are interested in to see what they're changed, and then they can refresh or update their slots. This is really simplified. There's a lot that goes into it. There's triggering, there's event triggers, and we're kind of extending this current subscription, FHIR subscription resource to be based upon the events. For this, it's to get. So say you have a scheduling app and you want to have a really quick turnaround time with, and you're servicing several different organizations, say 20 different organizations. So you don't want to have to rely on each EHR scheduler to give you in real time the availability. If you have a client that wants to see a doctor, they don't care where, for skin rash, right? And so instead of the application pinging 20 different organizations for their available appointments, come up with the best one, they just take all the raw data, the slot information, and they do the logic on their side. Yeah. So they have to do a lot of work on their end to get the business logic share the business. They have to share business logic. So each of those providers has to share their business logic, scheduling logic, and then they have their own algorithms to determine which is the best place to send their patient.
Like somebody that is going to go and look for a referring physician somewhere in the community.
Yes, exactly. Yeah. For example, I just moved to Boston. I have a skin rash. I want to see a dermatologist, right? I have no idea where. I go to my friendly little app and say, I need a dermatologist next Tuesday, or as soon as possible, and it says, oh yeah, here's one, on the other side of town that you can go see.
This is like cash.
Yeah, essentially, you're caching all the slots from 20 to. Yeah, It is a lot of information. And what we found is, the way of just simple polling is causing a lot of burden on the servers. Isaac. Exactly. So there's a question in the back. His arm's getting sore, his shoulder. Yeah, well, they've already done this work, like in travel, I guess. Yeah. I like the people I mentioned at the very beginning. Those are my experts, and in fact, one like ZocDoc, that's kind of one who kind of led the charge on this. So no, I didn't look specifically at. I personally didn't look at that, but I'm assuming that they have the expertise to have looked at how this was done in other industries. So I'm gonna qualify my yes, but probably. Any what? Not that I'm aware of. No. Okay.
For scheduling something like surgery, where you've got different types of resources that you're coordinating, this one's a question to you. Is the client app is merging all the information you find in that one intersection?
I don't think that we're not talking about surgery here because that's going to be kind of out of scope for our simple use cases for these simple visit types. But yeah, theoretically, yeah, you can evolve this to be able to do really complex business logic. But something like surgery requires a lot of business logic. I'm not sure even if I don't know what the EHR is going to send that and to offsite that. I don't know.
So just a super simple example that, like something that VA does with their telehealth stuff, they got to schedule the clinician, the room, the video conference equipment. So you're saying that this approach can't be used to figure out when is all these different resources available, and then the client app sort of merges that to figure out that one time that works for all the resources involved in this type of visit. That's not scheduled.
A lot of that stuff is simplified for the client. So instead of having, so I think that the way you would represent some of those like modalities in the room is all that would be like could be through as practitioner. And so and you don't have to the client doesn't have to figure out all of the practitioners that you need in order to schedule. Right? I think some of that is kind of handled as part of that operation and it doesn't
Okay, so Isaac is stealing some of my thunder. No, I appreciate that because one of the things this is important is, and I just want to reemphasize this, is if you just go with straight polling, you're putting a huge burden on a server, and I think you've guys experienced that. So you need to have a subscription where you're reducing the load on EHR scheduling services so they aren't constantly having these huge GET requests. So that's one of the benefits of doing it this way. And this is an operation. This is very similar to that other operation we talked about before, and let me pop out of this and I'll show you. It's called a prefetch operation, but it's very similar to the appointment availability. So here we have a prefetch operation, and really what this is doing is saying, give me some time period, and then here are our inputs. So this is both used to obtain the free slots for the so-called initial load. And then, you see, this is important. The server determines which open slots are exposed. So you wouldn't give them everything, obviously, if you're an EHR. You just give them what they can have. Okay, these slots are okay for a third-party application to schedule off of. And then what happens is if down the road, say you send the initial load out, but then there's a change in your schedule, and you decide that those slots, no, that physician or that provider, that service is no longer wants any appointments through a third-party app, then that gets changed. They get notified and they update their slots and and go forward. Exactly. So it's not only what servers are available, every time something changes, a schedule change means that there's going to be a change in the underlying slots. So any change in the schedule, then the third-party server will go back and it'll ping for all the slots associated with those schedules. And then it updates, it refreshes its slot cache.
Let's just say the central app has successfully booked an appointment within those slots. And now that the appointment is canceled, not there, but at the appointment entity. Does the central entity find out that that appointment was canceled? It has to. You think so?
Well, you still have to book an appointment, so you have to submit to the EHR an appointment.
Right, you can book it,
And then it can be rejected.
and it can later be canceled.
Yeah.
I'm also saying the EHR would have, if it was canceled on the EHR side, the EHR would have to broadcast it back to that entity.
Yes. Yeah. Okay. Okay, so let's go back. 4 minutes. Okay, so we're going to have to wrap up here, but this is a great conversation. I want to get the last few slides that we can talk some more about this. So, okay, so where are we at? Well, we had tested this out at a couple connect-a-thons, and the implementations that tested specifically, I mean, I did a little testing on a demo app, but as far as provider-based apps, Epic worked on the provider-to-provider-based application. I know Health Samurai, which I think changed their name, had implemented this, and I believe, Martin, you're adopting some parts of this for a Dutch implementation, right? Yeah, so they're using operations like appointment availability. Are you working on slots as well? Okay. Yeah. So, and there's other interest, some emails regarding this. So, again, the IG has just been published like 3 months ago, I think. 3 months. It was relatively new stuff. I wish that I could have, I wish that Brandon and Brian and Cooper were here too, because they could certainly fill in some more blanks than I can. Okay, so as far as future scope, we talked about future scope before, things like requests. Instead of just asking for an appointment, doing a request for something more complicated like a surgery. Using forms, doing this more back and forth so you get more information back before you make the appointment. And then merging with the provider directory so you have more discovery of what's available. There's a lot more future scope in the guide that we talk about. And then as far as what we're looking at right now, in HL7 and FHIR, the patient administration work group is looking at adding an availability operation to the FHIR specification. Yes? Yeah, when I say request, I mean that you make a request for an appointment, but you're not going to get an answer back. They have to corral all their resources before they can say yes or no. Does that make sense? I think we're talking about the same thing. Why don't you come up and we can talk about it afterwards? Okay. And then there's also this event pays this use case for pub sub using prefetch scenario. I've talked with Isaac about maybe using that as a scenario in an upcoming HL7 Connect-a-thon to help further mature the subscription resource. It's a good use case for that. Okay, time and internet access not permitting. Neither one's not permitting. I had this little based Flask app, but it just says you put in the availability and you get back, yeah, we found a couple appointments for you. If anybody's interested in that, I can try to hook it up. I have to reload all the stuff on the test servers. Okay, so looks like we're out of time. And if you have any questions, I'll be happy to field them afterwards. Thank you.